Okay, absolute values. I think the easiest way to do it is just to do this. On this one here, my sign's pointing here, just make a sign that says -2 right there in front of it. I'm already done. This one is an and, because it's less than looking for values that are smaller than 2. Well, the only way to be smaller than 2 with absolute value is to be bigger than -2. They got to be in between. So, no bar, open on -2, open on 2, and is colored in between like that. Coming over here to this one, notice the sign's going in, looking for values bigger than 5, and the way to be bigger than 5 on the absolute value side is to be a lot smaller than -5. That makes the bigger numbers. Now I'm going to start doing it this way. I'm keeping the sign going the same way, but I notice this is an or, because there's no way -5 is bigger than 5. However, this means -5 is greater than or equal to x, or x is greater than or equal to 5. I think it's easier to write it that way. I know I'm going to put, each have bars, so I'm going to have dots at -5, dots at 5. We're looking for values that are smaller than x, means smaller than -5, not smaller than x, can't be that. This way, and here I'm looking for values that are larger. And like I said, most of the ors are going to go out like this. These are the ors, elbows out, okay? It's not a guarantee, but I think most of the problems on this test, they're going to be that way. Here, I'm going to do the same thing. Just make my sign. It's definitely make that the -7. This one is an and, so I'm just going to add 3 to each side, plus 3 to that -7, plus 3. -7 plus 3 is -4, which will be less than or equal to 2x. Less than or equal to, and 7 plus 3 will be 10. I'm going to divide everything by 2. So I'm going to have -2, less than or equal to x, less than or equal to 5. These have bars, so I'm going to put a dot here at -2. I'm going to put a dot here at 5, and they're colored in between. All right, coming over to this one. I know it's an or, because I'm looking for values larger than 9. The only way it can be larger than 9 is if I'm bigger than 9 or smaller than -9. So I'm going to call this one an or. I'm going to write my -9 right there with my sign the same way, but I'm going to split it. 2x plus 5, or the 2x plus 5 greater than or equal to 9. And now work on solving it. Treat each one individually. -5 minus 5. -14 is greater than or equal to 2x divided by 2. I am not flipping the sign because I am not dividing by negative. I do have a negative here, so I have -7 greater than or equal to x, which if I want to go ahead and graph it, that's going to be a dot. I'll call this one here -7, and looking for values that are smaller, go in that direction. I'm going to -5 here, -5 there. This will cancel, so I have 2x greater than or equal to 9 minus 5 is 4. Divide each side by 2, and x is greater than or equal to 2. It will be a solid dot on a 2, because I just have a bar. And I'm looking for values that are bigger, which are like this. All right, coming over here to this one. Notice the absolute value has a 4 outside of it. I cannot do the and or ors until the absolute value is by itself. So the first thing I'm going to do is divide everything by 4. That will cancel it out. So now I have this absolute value of 2x plus 7 greater than 9. All right? Now then with it is a or. So I'm just going to go ahead and make that sign like here, -9, but I'm going to write it -9 greater than 2x plus 7, or 2x plus 7 is greater than 9. And then to solve it, I'm going to -7. -7 is going to give me -16. That's a 16 greater than 2x. Divide it by 2, so I have -8 greater than x. That's an open circle because there's no dot. I'm looking for values smaller than -8. I'm shading it out this way. Here I'm going to -7, -7. So I have 2x greater than, and 9 minus 7 is 2. Divide everything by 2, and x is greater than 1. It's an open circle on the 1. Whoops, I forgot to write my -8 there. My 1 here. Looking for values larger, so it goes that direction. Don't forget to put your numbers down here, because how do I know what it is particularly you graph? This one's very tricky. I have it multiplying here, subtracting, and then the absolute value. So let's get rid of this first. And I always undo the adds or subtracts first. So let's just add 4. So now I'm going to have -3 times the absolute value of 3x minus 9 less than -45. I now need to divide by -3. And that's going to cancel, and I divide this by -3. But here's the big thing. That is 3x minus 9. But guess what happens right here? That's -45 divided by 3 is going to be 15. But because I divided by negative, guess what has to happen to the sign? I have to flip it. It's no longer less than, it becomes like this. Now then, I'm going to go ahead and add the -15 over here, because that's what I've gotten. And this one is considered to be an OR, because there's no way -15 is bigger than that. It is an OR problem now. It's no longer, looks like it started out to AND, but it's not. It's an OR by the time you get it to this point. So I have -15 greater than 3x minus 9. That's a 3, trying to write real small here. Or 3x minus 9 greater than positive 15. I'm going to add 9 to each side. If I add 9 to here, that's going to make that -6 greater than 3x. Divide by 3. So I'm going to have -2 is greater than x. So I'm going to put a circle at -2. And the x has to be smaller, which is going to shade this way. I'll kind of shade it on the downside so we can leave all those numbers there. Coming over here, I'm going to add 9. Well, it's going to make that 3x greater than 24. Divided by 3, x is greater than 8. So we have an open circle on the 8, and I'm looking for values that are x is larger, which is shaded here. That one was an OR where they shaded out. Tried to shade the ORs in the red, the ANDs in the blue, so you kind of can see the difference between them. Those were graphing the absolute value problems.